In this video, we're going to discuss the pH scale. The pH scale is the way we measure the strength of an acid or a base. So as a reminder, an acid is a substance that when it's mixed with water produces hydrogen ions. And it has some very specific properties. It tastes sour, it turns litmus paper red, it can corrode metals, and it also will interact with carbonates. Like baking soda is a carbonate, and if you mix baking soda and vinegar, it bubbles up because vinegar is an acid. Bases are substances that when you mix them with water, they produce hydroxide ions. Bases turn litmus paper blue. Bases have a slippery feeling, they taste bitter, and they interact with each other, or they react with each other. You don't want to use a cleaner that contains ammonia and mix it with a cleaner that contains bleach because you'll get a toxic gas that's produced from that reaction. So we're going to take a closer look now at the pH scale. The P in pH stands for potential, and the H, which is capitalized, is for hydrogen. Hydrogen on the periodic table has a symbol capital H. So it's the potential to produce hydrogen ions. That's what pH literally stands for. And it's a range of numbers from 0 to 14 because we can determine the strength of an acid or a base and we give it a numeric value. When we look at acids, something that is acidic will fall on this side of the pH scale from 0 to 6.9. When we look at bases, something that is basic, or another word for that is alkaline, will fall between 7.1 and 14. In order to determine if something is acidic or basic, we don't want to stick our finger in it or taste it to see if it's sour or if it's bitter, because if it's a strong acid or a base, it can do some serious damage to our skin. So we use something called indicators instead, and an indicator allows us to safely test a substance to determine where it falls on the pH scale. This is a digital pH meter, and so when I turn this on and I place it in this substance, which we don't know what this is, I know what this is, but you don't know what this is, it gives me a measurement of 7.0. And 7.0 is important because that's neutral. It's not an acid or a base. This is actually water. So water should be neutral. Now, other pH indicators might look something like this or like this. If you have a swimming pool or if you have an aquarium, you're probably familiar with testing pH with an indicator to determine if you need to add chlorine to your pool or something like that. Not all indicators are the same. An indicator might only test between, say, 5 and 9 on the pH scale, because typically when you're testing your water, you don't need to have the entire range of the pH scale. This indicator tests for several things. One of them is pH. So if I take this and I place it in a substance like water, it may change some of these colors, and then I would match up the colors. But I'm going to show you something that's a little easier to read. This is pH paper, and this actually goes from 1 to 12. It doesn't cover 14 or 0. These little strips of paper look like this. Oops. And when I dip this into a substance, I can then match the resulting color to the colors on the side, and it will tell me where on the pH scale a substance falls. So we'll test water first. And when we look at the resulting color, you probably can't see that, but it's a little bit greenish yellow and orange mixed, and that's a 7 on our little scale. So it's neutral, luckily. Now we're going to test these other substances and see what happens. So this, we don't know what it is. It looks very much like the other substance. But when I dip my pH paper, I end up with something that's sort of a dark green. And that's around a 9 or a 10, somewhere between 9 and 10. This is actually bleach. and we know that bleach is a base or that it's alkaline. We're going to try this next substance, see what it does. Turns the litmus paper red. And that means that it's about a 2. This is vinegar, and vinegar is obviously an acid. We checked it with our indicator. There are also some things that you can use in nature that are indicators. Red cabbage, for instance, which is really purple, will turn, if you take the cabbage juice, it will change things that are bases blue, and it will change things that are acids to red. So that's a natural indicator. Other examples, for instance, are blood. Blood is slightly basic. It's about 7.4. You'll find blood here. That means that it's alkaline or it's basic. Over here, we're going to put our vinegar at 2. Vinegar is an acid. Now, the further you are away from 7, the stronger the substance is. So if it's 7.4, it's not a strong base. If it's 14, like drain cleaner, it's a very strong base. If you have something like vinegar, it's much stronger of an acid than something that falls at 6 on the pH scale. That's how the pH scale works to help us figure out what a substance is going to do in certain situations, and it keeps us safe as well. Hopefully that helps you to understand how we use the pH scale.